Hi students, I'm Anu Priyadashni, Assistant Professor, EC Department, SRM Madurai College for Engineering and Technology. Today, we will be seeing about demultiplexers in detail. Last class, we have seen multiplexers in detail. Today, we will be seeing demultiplexers, which is the opposite of multiplexers. So, this diagram we have seen already. The multiplexers have multiple inputs and a single output, whereas demultiplexers have single input and multiple outputs. So again here you can see here it takes a single input and routes into one of the many outputs here. Hence demux can be called as one to many, one input to many outputs, whereas mux can be called as many to one, many inputs to one output. So they are controlled by select lines which determine the output path. That is, the select lines or the control lines here determine which output the input is connected to. Okay. So they decide where the input should go. Okay. Which output should get the information from the input. That is decided by the selection lines or control lines. Okay. Applications of demultiplexers. Data routing in communication systems. That is, it is used in communication systems to send data from one line to multiple destination. Memory addressing in microprocessors. That is, it is used in CPUs to select memory blocks. Display systems to activate different segments in LED displays. And whereas serial to parallel conversion, they actually convert serial data into parallel data by routing it through demux. So this one we have already seen. I will explain again. So here is a single source, one system, one computer, and we have multiple destinations, that is 4 outputs. These are select lines. A and B are select lines here. If the select lines have 0, 0, the information from the system will appear at the laser printer. If the select lines has 0, 1, 1, the information X will appear at the fax machine. If it is 1, 0, the information will appear at D2, that is color inkjet printer, and so on. So DMUX has one data input 1 and n outputs, whereas multiplexers have n inputs and 1 output. So it is given as 2 power m in powers of 2 so that we can decide the number of control or select lines. We will see that in the types of demultiplexers. So you can see the types here. Wait a minute. Okay. You can see the types here 1 to 2, 1 to 4, 1 to 8, 1 to 16, and so on. So it is the corresponding select line here 1 select line, 2 select line, 3 and 4. How to decide upon the select line? We will see it in the next slide. Okay. First, we will see about 1 to 2 demux. 1 to 2 demux is 1 represent the number of inputs, 1, 2 is the number of outputs. So the outputs, I'm going to write it in powers of 2. So we have 2 and that can be written as 2 power. In powers of 2, how will you write 2? 2 power 1. So again you have here one number of select line which is given as yes. Only one select line. You have only one select line, one input and two outputs here y1 and y0. So we can see here if the select line has the value 0, the information I or a D or anything, if you have it at your own convenience, that will appear at y0. If the select line has the value 1, the information I will appear at y1. So 0, y0 will get the value I. For 1, I appears at y1. The remaining will be 0. So how will you write the minterms? Minterms 0 you will put bar 1 as such. So the first one for y0 you are going to write s bar into this I. For this one y1 it is going to be s because it is 1 into this I. So the corresponding diagram here. So the first minterm is s bar into y. So yes, not get s bar. So the output of the NOT gate will be S bar, and that into I, which is the AND gate here. So the output of the AND gate will be here S bar S bar into I. So you can see here S bar into I. Here it is I, S, AND gate, and output is Y1. So this is 1 to 2 demux. So 1 to 4 demux, 1 input, 4 outputs, 4. How will you write 4 as the powers of 2? 2 power 2. Yes, 2 power 2. Therefore, this demultiplexer will have 2 select lines. That is, from the power you are going to decide the number of select lines or control lines. So here it is 2 power 2. So from the power you are going to decide the number of select lines. Hence it is 2 select lines, S1 and S0. So if there are 2 select lines, there will be 4 combinations, 0, 0, 0, 1, 1, 0 and 1, 1. So if it is 0, 0, the information I will appear or will go to Y0. If it is 0, 1 to I1, the remaining will be 0 actually. If 0, 1, it goes to Y1, but the remaining things will be 0. That is the concept here. If it is 1, 0, it goes to Y2, remaining will be 0 here. If it is 1, 1, it goes to I3, the remaining will be 0 here. So this is the truth table for 1 to 4 demux. So corresponding minterms for Y0 you will write S1 bar into S0 bar into I. For Y1 you will write S1 bar into S0 because it is 1 into I. For Y2 you will write S1 into S0 bar into I. And Y3 S1 into S0 into I. Okay. So logic gate diagrams, S1, S0, the corresponding, I'll explain for the first thing alone. So from here, you're going to take I. So S1 bar, S0 bar into I. So S1 bar here, S0 bar, I, AND gate, and the output is Y0. So this is the concept behind 1 to 4 demux. So 1 to 8 demux has 1 input, 8 number of outputs, Y0 to Y0 to Y7. So 8, how will you write in powers of 2? It will be 2 power 3. So the number of select lines is the powers of 2, which is 3 here. S2, S1 and S0. Again, if it is 3, it has a combination of 8 here from 0 to 7. From 0 to 7, note the point. 0, 0, 0, Y0 will get the information I, input I. If it is 0, 0, 1, Y1, 0, 1, 0, Y2. Correspondingly, everything like 1, 1, 1 for Y7, 1, 0, 1 for Y5. So this is the truth table for 1 to 8 demux. So how will you write the minterm for this Y0? So Y0 will be S2 bar, S1 bar, S0 bar into I. You can see here S1 bar, S2 bar, S1 bar, S0 into this I. So this is Y0 and correspondingly you can write for Y1, Y2, Y3 till Y7. So this is the concept behind demultiplexers and multiplexers. Thank you, students.